Hey guys, this is the Chapter 2 video lecture. The name of Chapter 2 is Theoretical Perspectives in Motor Development. This will be a quick video. I just want to make sure that I touch base on the three major theoretical perspectives that have dominated the study of motor development over the last century or so. So you can go through the notes and look at some of this review, but really what I want to touch base is I just want to go over the three perspectives, or the three theories rather briefly, but I want to make sure that you at least understand the differences, or at least the characteristics of the three. Okay, the three theoretical perspectives that we'll focus in on are the maturational perspective, the informational processing perspective, and the ecological perspective. Okay. So the first perspective that was, accepted in the study of motor development, this was early on in the early 1900s. You can see here it was popular from 1930 to 1950, is the maturational perspective. This perspective posits that developmental changes occur as a function of the maturation process that control motor development. So, as the name suggests, that motor development, that the development of human movement occurs as a natural process, or occurs naturally during the maturational process. So no matter what happens, and again, this is in reference to this particular perspective, there's nothing that can affect that development. Okay, so no environmental factors, no external influences. It's all genetically controlled. That's pretty much what this perspective was saying. Okay. It says here that motor development is an innate process driven by biological or a genetic time clock. Environment may speed or slow. So environment is referenced not only just to the surrounding settings, but perhaps to external factors like parents or siblings or observing others, whatever. But it can't change the biologically determined course. Okay. So this was widely accepted in the early part of the 1900s. It wasn't until later on that we started to develop more thorough understanding of the development of human movement that kind of waned this perspective and moved researchers towards another perspective, which I'll talk about in a second. Okay. So one of the arguments of this, or one of the cases of this particular perspective, was a so-called co-twin study that was conducted in 1930. So again, it was almost 100 years ago now. So in the co-twin study, or the famous co-twin study of the time, the researcher Dr. Gessel performed an experiment in which he took a set of twins, and he put one of the twins through what he called the experimental treatment, in which that particular twin received specific training on stair climbing. Okay, the other twin didn't receive that training. Okay, and he just simply observed the effects of the ability to climb stairs throughout time. So naturally, the twin that was exposed to the training became proficient at climbing stairs, but they also noticed that the one that went through the control treatment also became equally efficient at climbing stairs. So though the one that received the experimental treatment became proficient sooner, it's the two twins both became as equally efficient eventually at some point. Okay, so pretty much what this is saying is that the ability to climb stairs or to engage in a particular motor movement, is going to happen regardless of the setting and the environment. It's going to happen just because it's genetically destined to happen. It's part of the maturation process. So you can't affect the maturation process. You can speed it, you can slow it down, but eventually everybody matures the same, and that's pretty much what the maturational perspective was saying. Okay. Also, part of this perspective was the development of the normative descriptive period and the biomechanical descriptive period. The normative descriptive period posits that, or at least assumes that basic motor skills are automatically materialized, and this led to the norms per age groups, and standardized tests. So when we look at norms, and here you can see a bell curve right here. This is called a bell curve, and what the bell curve is saying is that, yeah, some people will achieve higher than most, some people will achieve less than most, but most people in a group, if you put them through any type of treatment, any type of program, any type of whatever, most people are going to be on average, okay? And we can look at that, like if we were looking at the grades in the classroom. I mean, some people are going to be extremely high, some people are going to be extremely low, but most people are going to be, in the middle somewhere, okay? And the middle doesn't mean, 85. It just means that some people are going to be the high achievers, some people are going to be lower, and some people may be in the middle. Maybe it is a low A, or mid A, or whatever. I mean, it's not average. Doesn't mean 80, 70. I mean, it just means that whenever you take a group of people, regardless of the particular treatment, whether it's a course or a training program or an exercise session. I mean, some people are going to be better than everybody else. Some people are going to be worse than everybody else, but everybody else is going to be right in the middle. Okay, so so it's important to remember that the normative descriptive period, or at least the association or the development of norms when it comes to age groups. People at this age group should. This is what normally happens during this age group. You take. If every baby who's within 1 to 2 years of age should be walking by now, that's an example of a norm. Every baby or every toddler that's at least 3 years of age should be able to jump on 2 feet. That's a norm, and it allows for it at the time. It allowed researchers to identify, perhaps those who had some type of abnormality. If they weren't able to perform the normal test like other people in their age group, then it was an opportunity for them to identify abnormalities. Okay, and you can see some of these outcomes that they focused on: running speeds, jumping ability, and throwing distances. The biomechanical descriptive is very similar in that it allowed researchers to notice particular abilities to perform certain movements. So we know that and eventually we're going to look at this starting next period. That we know that a baby should be walking around 1 year of age. But with the biomechanical descriptive perspective, these people or these kids or these infants or toddlers, and I don't know exactly what you call them, they should demonstrate particular movements, I guess, in relation to walking. All right, so for example, I mean, you can't expect a baby just to get up and start walking. The baby, over the course of several weeks, starts to, kind of grab a hold of a furniture. We call this cruising. Grab a hold of furniture and kind of starts to demonstrate, trying to attempt to stand upright, but they're, kind of rocking, trying to gather their balance. Okay. This is what the biomechanical descriptive period was saying, or at least this perspective was saying, was, Yes, I mean, these are noticeable characteristics of those who develop particular patterns of movement. At first, there's some awkwardness. At first, there's some jerkiness. There's some imbalances. There's some lack of coordination. But, according to the normal development of movement, this is part of the process. To eventually, they're able to stand upright without rocking. They're still having to hold on to a furniture or something, to maintain their balance. But at least they're not rocking. They're not as awkward. They've developed. They've gotten better at trying to perform this particular movement. And we notice that with anything we do. I mean, the first time you pick up a baseball, for example, and you throw it, you don't look like a proficient thrower. I mean, there's some awkwardness. I mean, after a couple of attempts, perhaps you can become better and better. But this is the noticing or the observation of the development of movement and the patterns of movement and the proficiency or the efficiency of movements was a big part of this particular perspective. Okay, so when we look at the maturational perspective overall, I want you guys to be able to associate the normative descriptive period and the biomechanical descriptive period that are associated with this maturational perspective. Okay. The second perspective is the information processing perspective. This took hold later on in the 1900s. You can see it was popular from 1970 to 1990. And it posits that the brain acts like a computer, taking in information and processing it and outputting movement. So pretty much movement was, or the development of movement, according to this perspective, was attributed to observations. So whenever a toddler or an individual observed movement, according to this perspective, they should be able to mimic that movement just based on observations. Okay, so it was almost like a stimulus response connection. Okay, and according to this perspective, it happened in young adults and older adults and children. So all the same. Okay. But the most current perspective that has become accepted was the ecological perspective, and you can see it emerged around 1980, and really it still dominates the study or the theoretical perspective of motor development even today. Okay. So this posits that the emergence of motor skills is determined by the interaction of all constraints. And that's why we have implemented Newell's model of constraints, so that we can understand, how motor development occurs. Okay, I like using a jump shot, for example. Whenever you look at a 5-year-old who shoots a basket, now very few 5-year-olds will actually shoot like a real jump shot and look like a proficient shooter. But for the most part, a 5-year-old who doesn't have the strength, they have the ability and the thought process to get the ball in the hoop, but physically they just don't have the strength or the coordination to be able to shoot a proficient jump shot like a proficient shooter does. What they do is they shoot from the hip, and they use their entire body to push the ball into the air. Okay, so according to the ecological perspective, and if you guys know the term ecological, it means multiple systems. Okay, so there's lots of systems that are involved in a proficient jump shot or a proficient anything related to human movement. What are those systems? Well, those systems could be cardiovascular system, the muscular system, the skeletal system. I mean, all of these systems have to be at what's called a critical level in order to become an overall proficient motor skill. Okay, so for example, let's look at System 1, for example. And you can see in this particular example, System 1 is already at a critical level, meaning that it's adequate enough in order to contribute to the overall movement. So let's say this system is the cardiovascular system. Okay, the cardiovascular system of a toddler opposed to or compared to an adult is the same. I mean, there's heart, there's blood vessels, there's blood pumping to the muscles, oxygen being delivered to the muscles. Everything's there. Okay. Now system 2, where it says system 2, let's say this is the skeletal system. Okay. Now it hasn't reached, let's say here, so at 1 year, at 0 years of age, and here's 1 year. So about, it takes about half the first year of life before the skeletal system is ready to engage or contribute to that particular system. All right. Now, the years are, I mean, the time at the bottom, may differ from what actually happens. But what I'm saying is, system 1, let's say system 1 is the cardiovascular system, it's already ready to go. The skeletal system hasn't quite developed until about halfway between these two points of time, which in this case is 0 years to 1 year. But if we're talking about shooting a basket, it may be between 1 year and 6 years. I mean, just depending on how long it takes for the skeletal system to develop enough to where it can adequately contribute to that particular movement. Okay. The third system, perhaps this is the muscular system, and you can see that throughout the entire time the muscular system hasn't quite reached the critical level until the very end. Okay. And then let's say this system number 4 is, let's just say it's the nervous system. And you can see that, between the time points in this case, again, it's 0 to 1 year, but it could be, 1 year to 7 years, whatever. About halfway, it finally reached the critical level. Okay. So what the ecological perspective is saying, or at least the dynamical systems approach is saying, is that this overall motor skill, so let's say the motor skill is a proficient jump shot, not a jump shot from the hip, but an actual jump shot where the shooter jumps up in the air and shoots from the forehead, can't be achieved until all of the systems associated with that movement have finally reached a critical level. Okay? And that's whenever the overall motor skill reaches its critical level in order to be able to perform proficiently. Okay, so in that case we have rate limiters, and the rate limiters are the systems that require the longest time to develop before that system adequately contributes to the overall skill. Okay. The ecological perspective also delivers or also provides us with the perception action approach, which suggests that there's a close relationship between the perceptual system and the motor system. So in other words, whenever you engage in an object or an activity, and you may notice this this may be noticeable or it may not be noticeable, but either way, we do look at the object or the setting or the situation, and we perceive whether or not we could actually perform or complete the task with confidence.